Right, so example 11 is very similar to the previous one. We've got an algebraic setup, and we eventually need to get to the fact that an expression that links y and x, and we'll see what y and x is in a moment. But we're going to start by drawing a picture, right? So we've got that something is launched into the air, tells you the initial velocity is u, and the angle is alpha. So we can draw the trajectory of that object. Okay, coming back down to land. And then the extra bit here says that when the particle has moved a horizontal distance x, its height above the point is y. So that tells you if we take the general point where it is, it's telling you that this length here is y, and this length here is x. And then we're going to try and end up with this general expression. It doesn't look very nice, but I'm sure we'll be able to manage it. That looks like that. So there's only two things you can do on a projectiles question. You can do solve that vertically, and you can do solve that horizontally. So we're going to do both of those things. Let's start off with the vertical, but we could easily start with the horizontal as well. So when we're doing it vertically, we write down what we know. We know that A is minus 9.8. It's always minus 9.8 vertically because of the gravity. We know that U is U, but then it's going at an angle, so to get vertical, we have to go away from the alpha. We move the U here, so that's a sine of alpha. We know that S is equal to Y, right? That's the displacement in the positive direction. And then we need one more thing, don't we? So we need either time or final velocity. Now we don't know anything about final velocity at this point. It'd be very hard to say what final velocity is. But what we do know is that the time when we're in this position vertically will be the same as the time we're in this position horizontally. So time is really important. So I'm just going to call time t. And then what we can do is we can take all our information and we can put it into SUVAT. So this will be S equals ut plus a half at squared, which gives you y equals u sine alpha times t minus, and actually, sorry, we've got g's in the final answer, so we shouldn't use minus 9.8, we should use minus g. Right, if there's g's in the answer, it doesn't want 9.8, it wants the g. So minus 1/2 gt squared. Okay, so that's all we can do for now for there. We have got it in the form y equals, which is what the answer wants, right? The answer is y equals, so that does look promising from that front. But let's go away and let's resolve it in the other direction now. So if we resolve and look at what happens horizontally, we have that A is 0, because it's always 0 horizontally. We have that S is x, that's a setup of the question. We have that U is U cos alpha, right, because we've moved through the alpha to get there, so it's U cos alpha. And again, we'll use t because it links the two variables. So again, when we do S equals ut plus a half at squared, well, just like on all of these questions, right, where we do it horizontally, there's an a here, so this whole term is going to be 0, right, because when you put 0 in, it'll kill the whole thing. And we've got S is x, U is U cos alpha, and of course t is still t. So we've got two equations there, right, simultaneous equations, lots of variables, u, t, alpha, x, y. And this way you have to be a bit of a detective, right? So we look at what we've got up here, and we see that in our equation we've got y's, x's, alphas, u's, g, x's, but what we don't have is any t's. Which leads me to conclude that what they want us to do next is to eliminate the t's from our equation. And the easiest way to eliminate our t's would be to rearrange this formula. Because if we divide through by u cos alpha, we have that t is equal to x over u cos alpha. Right? That's helpful because then I can substitute into that, and then hopefully it's going to end up looking like what the question's asking us to find. So let's go back to the top of the page over here and let's try and do that. So I'm going to use this equation here, and I'm going to put in, instead of t, x over u cos alpha everywhere. So what we've got, y equals u sine alpha times x over u cos alpha minus 1/2 g x over u cos alpha squared. Okay, then I'm just going to try and neaten it up, and I'm going to try and let myself be guided by what I'm trying to get to in the question. So Let's see what happens when we're neatening it up. Well, firstly we look at this bracket. We can see when we multiply them together there's a u on the top and there's a u on the bottom. So they will cancel very nicely. And we're left with x sine alpha and then over cos alpha. So I'll just write the over cos alpha with a sine alpha because we can see what's going to happen there hopefully. Then on the other one I'm going to square everything. So minus a half g x squared over u squared cos squared alpha. Next line, that sine alpha cos alpha is going to go to a tan alpha, which actually if we look at what we've got is exactly what we need, an x tan alpha. And then this next term, well what we've got here, we've got gx squared over 2u squared times by 1 plus tan squared alpha. So what I'm going to do is I'm going to put everything that's not the cos squared alpha as one term and see what we get. So the g will go on top, the x squared will go on top, and the 2 and the u squared are on the bottom, and this will all be multiplied by 1 over cos squared alpha. Then again, at this stage, I go back and I consult what I've got at the top here. And you can see that y equals x tan alpha, that's good, minus gx squared over 2u squared, I've got that as well, but then I've got a problem with my 1 over cos alpha. Right, so either something's happened and I've made a mistake, or 1 over cos squared alpha is equal to this. So we think back to our trig and we can go to the side at this point. So I'll do a little aside in a different colour. What is 1 over cos squared alpha? Well, 1 over cos squared alpha is equal to sec squared alpha. And actually, again go to the side, what are our formulas that link these? Well, going from sine squared alpha plus cos squared alpha equals 1. If we divide through by cos squared, we get that tan squared alpha plus 1 equals 1 over cos squared, which is sec squared. So actually, I can substitute in my sec squared for a tan squared alpha plus 1. Right, so leave that in brackets there just to show what we've done. Then we continue again in the original colour, because this is x tan alpha, y equals x tan alpha minus gx squared over 2u squared, and my 1 cos squared alpha can be replaced by tan squared alpha plus 1. Well, actually they've written it the other way around, so let's write it the same way around as them, so that we can really explicitly see that we've done it correctly. Okay, so it's all about looking at what you're supposed to get and using that as a prompt to remind you that you can substitute 1 over cos squared alpha to get tan squared alpha plus 1. Part B then moves on and asks you to use what we've just done. Well, it doesn't explicitly say it, but you know, if you've done a part A where you've done some difficult algebra and then they give you some numbers, we're hopefully just going to substitute those numbers in. So let's have a look at what they tell us. A particle is projected from O with speed 28, U is 28, at an angle of alpha, so they've still not given us alpha, but then it says it passes through B, which is a horizontal distance, well that was x, and a vertical height of 8. Find the two possible values of alpha. Okay, so what I'm going to do is I'm going to take these values and I'm going to put them into my equation up here. So we've got the, let's have a look, 8 is equal to 32 tan alpha minus g times 32 squared over 2 lots of 28 squared multiplied by 1 plus tan squared alpha. Right, so then I'm going to collect up my fraction here, see what this all comes down to. 32 squared divided by 2 times 28 squared. And I get a very nasty decimal. Alright, so I'm going to times that by 9.8 as well for the gravity. And actually, it comes out a bit nice if I times it by 9.8. So what we get is we get that 8 equals 32 tan alpha. Apparently this is 6.4, 1 plus tan squared. So then I'm going to expand that bracket, being careful that the negative applies to both parts. Hopefully what you can see is you've got a quadratic. And your quadratic is in terms of tan alpha. So I'm going to put them all on the same side and collect up like terms. 6.4 tan squared alpha minus 32 tan alpha plus 14.4 equals 0. So So it's a quadratic, but the quadratic is in terms of tan alpha. So what we're going to do with that is, well, we can either try and get it to a point where we're going to be able to factorise it. Might be quite difficult, we've got some decimals, could try and eliminate them and simplify it down, there'd be nothing wrong with that. Or we could put it straight into the formula this time. I'm just going to try and eliminate decimals and simplify it down. I think that sounds more exciting. So if we times it all by 10, we get 64 tan squared alpha minus 320 tan alpha plus 144 equals 0. Then I can look for common factors. I think looking at that 16 is going to be a common factor. So this is 4 tan squared alpha minus 80 tan alpha plus 9 equals 0. And again, still not much help, is it? There's no more common factors. I can't divide by anything common there. So I could still try and factorise it, but actually what I'll do is at this point I'll use the quadratic formula. So if I go on my quadratic formula solver and I put in those values for minus 80 and 9, oh no, actually I've made a little mistake here, haven't I? We divided by 16, we should get 320 divided by 16 should just be 20. Which actually looks much more promising. I can actually factorise that. So if we take a little look, we should have, let's see, are we going to have 4, 1, or are we going to have 2? Yeah, we're going to just have 2, 2. So it's 2 tan alpha minus 9 and 2 tan alpha minus 1 equals 0. So that gives you that tan alpha is 9 over 2 and tan alpha is equal to 1/2. Very nice. Then we can just do inverse tan on each of them and we should get our two values of alpha. Inverse tan of 4.5 gives you 77.5, and the other one, inverse tan of 0.5, gives you 26.6 degrees. So there are two possible angles of projection. Just as a final point, why are there two possible values of projection? Well, if we were to draw what this represents, if we think about what we're looking for the time that we're looking for a projection that goes through, say, this point here. And there will be two options. One option will be sort of the low option where you're hitting it on the increase and comes down. And the other one is where you're hitting it on as you come back down to Earth. So firstly we end up going up, then we peak, and then we come back down, and there we go through it just the same. So one of them, obviously the orange one, would be the 77.5, and the pink one would be the 26.6. So there's two solutions for getting through that point with that speed of projection. So that's the end of this unit. Final thing for you to do, obviously, is exercise 6D. I would do question 1 and 2, they're most like the examples. So you can follow the examples. Obviously, it goes without saying when we put all the algebra in, it is trickier, but it is the same process beneath it all as we've been doing the whole time. After that, and then choose a couple more. So choose some of the others that you want to do from that exercise, right? And give yourself a challenge and see how you get on with that.